Now, have you ever wondered what the other side of the moon looked like? I have I have wondered my whole life, you all, what the other side of the moon looks like. This is what it looks like. Right here, I saw it today. It was like when I got on my laptop this morning, there was an article, and it was showing the other side of the moon. So if you haven't seen it, this is purportedly what this moon looks like on the other side. Even though it says it's like locked into orbit with Earth, you only see that one side. It's like it got a tractor beam on it, and it's just like moving it around in a circle. That's why you only see the one side, because like a tractor beam. Now I'm just saying it's a tractor beam. That's the only thing I can describe it as, if like on Star Trek, when they got a tractor beam, boom, around that, locked on that moon. That's what it's supposed to look like. That's right. So it took me a little bit longer than 10 minutes, I think. But that's okay, you all. It can take me longer. It can. It's all right, as long as we get to see this other side of the moon, the dark side of the moon. It doesn't look too dark, but I'm sure it's a tad bit different looking. I would say that it is different looking than the side that we see, which is really interesting. Let me put my phone over here. So I want to see the comments, you all. I really do. I want to see your reactions when you look at this other side of the moon, because never seen it before. I didn't even know that we could even have an image of the other side of the moon, but we do got an image of it. And yes, that's right. I am going to twirl around. I am going to twirl when we all stay loved at the moon. Twirl in your last video. That's right, you all. We got it. This is supposed to be the other side of the moon. So let me move myself out of the way. Let's look at this, you all. This is what it's supposed to look like, the other side of the moon. And we're going to look at the article that I got these images from. So this is the side we always see. And sometimes, this spot right here, the moon does rotate like that, like clockwise in the sky, or counterclockwise. Look at that really dark area right there in the center. You can't see it that well because I'm not in here. Yeah. So let me put myself back in here, you all. Let's go to that article. If you're just joining in, hello, you all. This is going to be exciting. Now, it's kind of a long article, you all, but that's okay. I'll read it to you, for there are people who do not like to read because it makes them tired to read. I like to listen to other people read, as long as they've got a voice that my spirit can listen to. It's all about the tone of the voice, you all. It really is. We can do it. Where is the whole going inner moon? Well, I don't know. We're going to read this article. We are going to do it. We can do it. We can do it. Hello there, Susan B. Honey. We are on here, you all. We got it going. We get to see the other side of the moon, in case you have never seen it before, because I have never in my life seen the other side of the moon. And it's going to be exciting, you all. Let's do this right here. And yes, we need to play, Michelle Honey. Michelle Honey, where'd you go? Yes. That's right, you all. Here we go. The other side of the moon. Look at this. It's called the Big Think. So it starts with a bang. September the 28th, you all. And we are going to put this right here. That's what we're going to do. We're going to come on over here, and we're going to put this reference right here, because REFERENCE, find out what it means to me. That's right, but it's RESPECT, but we're talking about reference. Right there, you all. We can even do it like this, because it's quite simple. You just do cut and paste. And voila, we're back over here where we started. Why the moon's two faces are so different. The far side of the moon. Excuse me. I should have said the far side of the moon instead of the dark side of the moon. Is incredibly different from the Earth-facing side. 63 years later, we know why the moon's faces are not alike. Yeah, so we know why their faces are not alike. Let's look at this. We want to look up the close images of it. Look like it's got like lines going through it, don't it, you all? To you, this moon right here. And let's go down a little bit slower. Gina, get out of the way. I'm out of the way, you all. Let's get a little bit slower so you can see it. You can see the lines going through it. It's got a lot of craters on it too. It really does. So this is the side that we always see, and it does do some rotation on its own. It does. And then this is the far side. This is the side we don't ever get to see right here. So let's look at all these craters. It does kind of look like a slice of cheese. Well, look at this. It looks like they put it together. If we look here in the center, like right here, they put the two halves of the moon together. That's what it looks like. Straight down through there. This looks like a familiar hole with a shadow on it, but this is the other side of the moon. Right here, you can see down here where it looks like it's been put together too. I guess as a satellite or something goes over it, it takes images and they have to paste those images together. You think? Perhaps? Yeah. Okay, so this is what they both look like. I'm not going to touch it. Okay, we got it. Yes, we got it, you all. Boom! That's right, we got it. Okay, now this is an article. So let's cool down. It says this is a NASA GSFC Arizona State University. This two-phase mosaic from NASA's Lunar Reconnaissance Orbiter shows the near side and the far side of the moon with a modern technology. We only glimpsed the far side for the first time in 1959. Well, why didn't we get to see it? And it took 55 years to learn why it's so different than the near side in the terms of craters, Maria, and crustal thickness. Did you all know that? They saw it in 1959. Well, is this called the far side right here, the one we always see? Yeah. Your dog is barking at your shampooer. So the near side of the moon has faced the Earth for practically all of the last 4.5 billion years. Earth's inhabitants have gazed upon its iconic mountains, finally flew a spacecraft around the moon to the opposite side, the far side of the moon, and saw a face that was entirely different and virtually unrecognizable. For more than a half a century, we've puzzled as to why these two sides of the same planetary body were so different. Thanks to the physics of early Earth, we might finally have the answer. So, that's what it looks like. Yes. The images that NASA puts out of the moon have changed dramatically over the years. That's interesting. Yeah. You know that, you can read along with me, or I can just put the image on here and we can just listen to this right here, read the article for us. Did you want to hear the article read by the person who wrote it? Because it can do it. And I wouldn't read it if you wanted to listen to the article, because we're given the ability to listen to it. That's right. We can listen to the article, or I can read the article. We got to have a vote. That's right, you all. No. Okay. The moon, by far, is the brightest object and the largest object that's visible to human eyes in the Earth's night sky. Compared to Venus, the next brightest object that appears, the moon, is 30 times the diameter and takes up almost 1,000 times the surface area and appears about 1 million times brighter than Venus. Moreover, the moon doesn't appear as a uniform disk to us, but rather shows incredible differences from place to place across the surface, even as viewed from our limited perspective here on Earth. To the naked eye, these differences might just appear as bright and dark patches. The so-called man in the moon is the easiest feature to see. But if you take a look through a telescope, you won't just see those dark spots silhouetted against the brighter portions, but also mountain ridges, craters with high walls and rays splaying out from them, and shadowy relief along the night-day boundary known as the moon's terminator. Although these features might be familiar, they all hold clues to the moon's ancient history and can help us understand why the face of the moon that we see isn't the only perspective that matters. So this is from NASA's Reconnaissance Orbiter Wide-Angle Camera, the Maria. The prominent craters, plus walls, rays, ridges can all be seen. It was quite a shock when they discovered this view of the near side of the moon was not replicated on its far side. So let's look at this, you all. So the the Mare Frigoris. Okay, this is the sides we look at. The Sinus Iridium, the Mare Imbrium, Archimedes, Mare Serenitatis, Poseidonus, Mare. Why do they say Mare? Are they saying Maria? I don't know what it is, you all. Nubian, Humoran, Shikard. Sounds like Picard. Aristarchus, Aristotle, Aristotle, Copernicus, Mare, Nectaris, Ptolemus. You all, these are big some kind of words, Latin words maybe. C. Okay, that's C. Okay, y'all. So we can see that's really neat. I didn't know that they had names. I didn't at all. Well, now we know they got names to them, these dark patches, which is pretty interesting in itself. It is. That's right. It's interesting. So with even an off-the-shelf pair of binoculars or the cheapest telescope you can find, there are two main features about the moon that you cannot miss. That it's heavily cratered, and that the lighter colored areas are generally more heavily cratered than the darker areas. Many cratered regions include small craters inside the medium-sized crater inside giant craters, which provide evidence that the larger craters are so old that newer, smaller ones formed on top of them. That is, that it has these dark areas known as Maria, which is Latin for seas, which have relatively few and mostly smaller craters in them. These regions are notable for being a significantly different color and composition than the majority of the moon. It's true, this is a really neat graphic, you all, that they got going. It's true that the same side of the moon always faces us, but different portions of the lunar hemisphere get illuminated throughout the month, dependent on the relative positions of the Earth, Moon, and Sun. Isn't that neat, you all? They got this moon doing like a wobble. It says, although the moon is tidally locked to the Earth, that the same side always faces our planet, the fact that the moon's orbit is elliptical and follows Kepler's laws of motion ensures that it appears to rock back and forth over the course of a month, a phenomenon known as lunar libration. Overall, 59% of the total lunar surface, now not 50%, is visible from Earth over time. Only 59%, you all. That's not very much, but look at that. Isn't that pretty neat? But it's not only doing that, you all. It's like it's rotating. It rotates in the sky like every 15 minutes or so. It does. Penny, you can be right back. That's right. Just goes back and forth, you all. Look at that. Look, it has oh, this is a real, it's a real thing. So this is November of 2007, October of 2007. Oh, it's going through the months and days. Okay, it's not showing the smaller movements of the moon either. So that's what that's doing. Okay, now I understand that it's not just supposed to be a whatever, you all. That's right, the moon is doing it. It's going back and forth. It's a pretty good image, a little video thing of it. It is. It looks neat. In addition, because the moon's orbit is elliptical, moving faster when it's closest to Earth and slower when it's farthest away, the face of the moon that's visible changes ever so slightly, a phenomenon known as a lunar libration. Even though this means over the course of many months, we could see up to a total of 59% of the moon. And it wasn't until 63 years ago when a Soviet spacecraft, Luna 3, swung around to the far side of the moon that we got our first pictures of the far side of the moon. So if you're all just tuning in, we're looking at the other side of the moon, the far side of the moon, the dark side of the moon. That's what this article is about, which is pretty interesting. I've never seen the other side of the moon, like a lot of people, so it's going to be neat. Although it wasn't very impressive in terms of image quality, it was remarkable for an unexpected reason. The near side of the moon appears vastly different in terms of both cratered features and Maria features from the far side that always faces away from us. This discovery came as quite a shock, and for decades, even as our imaging and understanding of this elusive side of our nearest planetary neighbor improved in quality, we lacked an explanation as to why this difference existed at all. So that's the images, you all, and they kind of look like they cleaned up the images a little bit, which is pretty cool, I guess. Yeah, it's pretty cool. A, B, C. I guess they're showing it kind of rotating. Yeah, I think that's what they're doing. So what are the big differences between the near side and the far side? One thing you'll notice right away is that the almost complete absence of the dark Maria on the far side. There's one prominent one on the moon's northern hemisphere, but it's small. There are perhaps a few smaller, shallower, connected ones in the southern hemisphere, but none of them are as wide, deep, or sweeping as any of the ones on the moon's near side. The Maria are vastly different between the near side and the far side. Perhaps the second thing you'll see is how much more prominently and thoroughly cratered the far side is, with so much more surface area than that is devoid of these Maria. There are more regions that appear to be older and more heavily cratered. That leads to more craters and rays appearing to radiate from them, from the inside of them, from out of them, even crossing one another on the far side. So if these craters are older and heavily cratered, they're saying that's why there looks like rays of light coming out from beside them. Isn't that interesting? Because some of them look like a door on the side that we see. Like I got an image of it one time. It literally looked like a rectangular door with a light in it, you all. Let's look at this. Although this was first discovered all the way back in 1959, it took a lot longer to come up with a reason for this mystery. You see, there's an obvious explanation. Well, what is the explanation? That perhaps you even thought of it yourself, but it turns out to be wrong. Oh, wow. Okay, that's fine. Fine and dandy, you all. Look at these craters. Some of them are perfect. Some of them look like moonfall. It does. Yeah, that's right. It does look like blasts on some sides. Our experience tells us that the solar system is full of hazardous comets and asteroids, and periodically plunging into the inner reaches of our star's vicinity. When things go well for the inner worlds, these bodies produce spectacular displays like cometary tails and meteor showers. But when things go poorly, one of these large bodies smacks into a larger one, creating a catastrophic impact. And if there's life on the world that gets struck, a potential extinction event. Oh, so we'll see an extinction event. The obvious explanation would be that when these massive space rocks head toward the moon from the far side, there's nothing at all getting in the way, and every object that would strike it absolutely does. But when you approach the moon from the near side, the Earth is in the way. And that way we can act as a shield for objects that would otherwise impact the moon's near side. And in doing so, the Earth could either absorb those impacts on a gravitationally deflect those potential impactors away from the moon. That's the obvious explanation. Look, they got a little visual right here, you all. So if there's stuff coming toward the Earth, Gina, get out of the way. Toward the moon, the Earth is going to deflect it. Well, then we should have big craters on it, shouldn't we? Have big craters on the Earth, you all? You think we should? I don't know. I really don't know. If you're just tuning in, we're looking at the other side of the moon. And we're reading an article from thebigthink.com is what we're doing. When we look at the details of the Earth-Moon system, does this explanation hold any water? That's the Earth-Moon to scale. Earth and the moon. Is the moon that small? 384,400 kilometers. Okay, well, we can see it. It's a nice attempt at making sense of what we see, but the fact is that the Earth-Moon distance is some 40 times larger than the diameter of the Earth, means that the difference in the number of impacts on the near side of the moon from the far side ought to be less than 1% when we run the numbers. And that's simply not the case. The far side is something like 30% more heavily cratered than the near side, a tremendous difference that cannot be quantitatively explained by this gravitational deflection event. Additionally, this explanation offers no differences for the abundance of the size of the Maria that appear on the near side versus the far side. And impacts aren't thought to cause these. They're the result of basaltic lava flows. The fact that the Earth offers a small amount of planetary protection to the moon's near side simply can't account for that feature. So what does that account for? So what does account for the differences between the near side and the far side? The answer, it turns out, does have something to do with space collisions, but not from comets and asteroids. So look at this. So look at this. I got another little visual right here, you all. Isn't that cute? That is so cute. Let me move this over here, you all. That looks really cute. Do you think the moon's that small? Look, we even got that. Hey, what's that UFO doing up there? Look at this, you all. No, see that right there? That right there looks like some kind of a structure in the clouds twirling around right there, you all. You knew we was going to find a UFO or something like that on here. That does not look normal. Can you see it? I gotta get it, you all. Yeah, let's get an image of it, because that don't look normal, you all. We gonna go look at it. That does not look normal right here. You see that thing right there? That don't look normal. Oh, beg your pardon. Oh, it said there's nothing to show here. Okay, well, let's look at this. See, that doesn't look normal, you all. What's that? Okay, there you have it, you all. There's nothing to see right there. Nothing at all. That's right. That's right, you all. So that looks really cool. And that looked like some type of structure or something up there in the sky, making that shape up there, you all. Hello there, Apple Brooks, honey. So let's look at the rest of this, you all. So compared to everything our planet has experienced over this past 65 million years, the asteroid that wiped out the dinosaurs was a big one. It was roughly 5 to 10 kilometers across, or the size of a very large mountain. But if we go back to some 4.5 billion years in history, we learned that the Chicxulub impactor was absolutely not the largest collision in Earth's history, not by a long shot. We didn't even realize this, but until we brought back rocks from the moon and discovered that they're made of exactly the same stuff as Earth is made of. This was a big surprise because no other moon, planet, companions in the solar system, not Jupiter or its moons, not Mars or its moons, not Saturn and its moons, are like that. Why would this be the case? Some 4.5 billion years ago, when the solar system was still in its infancy, the Earth was mostly formed and was around 90 to 95% of its present mass. But there was another very large Mars-sized, let's get this. This is what I'm talking about right here. They say that there was a very large Mars-sized planetoid thing that was in an almost identical orbit to Earth's. For tens of millions of years, these two objects unstably bounced away from and toward one another. And then finally, about 50 million years after the solar system formed, they collided with one another. Oh, wow, that's a nice graphic. Look at that. Isn't that a nice visual? That looks pretty neat, you all. They did, I don't know how people do stuff like that, but they're really good at what they do. Well, I guess you could do that with a green screen. Don't that look neat? That's right, you all. This is their version of what happened to the, I guess, the moon and something else. What is this? What are these cracks? They got the cracks on the moon, you all. Look at these cracks and fissures. Oh, wait till you see, you all. Wait till you see some of the images on here, you all. You know what it looks like? It looks like Nibiru when you look at some of the images they got on here. It's wow. I thought, wow. Yeah, this is pretty cool. We're getting close to them, too. We are. We're getting really close to them. So that looks pretty neat. So the vast majority of both protoplanets wound up forming Earth, while a large amount of debris was kicked up into space. Over time, a significant amount of this debris coalesced gravitationally to form the moon, while the rest of it either fell back to Earth or escaped elsewhere in the solar system. As crazy as it sounded when it was proposed in the 1970s, this has come to be the accepted theory, verified by many observable phenomenon that match the predictions over the past 40 years. Additionally, there's now scientific evidence that the moons around other rocky worlds like Mars and Pluto's likely formed from giant impacts as well. The collision, see, y'all, look at this, you all, look at that. So the collision must have happened very early in the solar system's history, and the Earth was still very hot when it happened, around 2,700 Kelvin. The moon that formed initially formed from a disk of debris that would have been exposed to the very hot Earth as it was forming, and there are a few details we're pretty confident in. Let's look at this. The moon was likely located much closer to us initially. It likely became tidally locked after a very short time, 100,000 years or less, and maybe have even been born tidally locked, having lost its excess spin, angular momentum, even prior to its completed formation. Look at that. That looks like that Nibiru in the sky. It really does. When you look at the FAA live webcams and stuff, you see an object up there that's red with these craters and stuff in it, you all. We really do. That's right. The last detail is not presently known, but remains a strong possibility that maybe it had been born tidally locked, having lost its excess spin, angular momentum, even prior to its completed formation. So if so, there's a big effect from having that extra heat source, the Earth, close by in terms of what materials are available to the moon on both the Earth-facing and the away from Earth sides as it's forming. So look at this, you all. About 50 million years ago, it was the Earth, after Earth was formed, it was struck by a large Mars-sized object named Theia. The aftermath of the collision superheated the Earth and kicked up an enormous amount of debris, a large fraction of which wound up forming the moon. The remainder either escaped the Earth-Moon system or fell back onto one of the two bodies. While the moon's far side cooled more rapidly, the near side, due to its facing the hot Earth, remained hotter for much longer. That's really, I've never heard of this theory before. Have y'all heard of this theory before? I've never heard of it before. That looked like a shadow up there on this one right here. I've never heard of that theory. It sounds kind of interesting. I like the cool graphics they got in this article. I really do. They look neat. So look at this. It was only in 2014, a whopping 55 years after we first glimpsed the far side of the moon, that a study by Arpita Roy, Jason Wright, and Stein Sigurdsson appeared to have synthesized this complete story and presented the necessary evidence to support it. You know, I bet you can click into here and let's see where it takes you. Oh, look, you can click in there and you can see these things. So yeah, you all, that's pretty neat. So you can find these things inside this article. And I won't click into all of it. Well, that's okay, you all. Let's see. We can look at this. We can look at these because the links are already. The Astrophysical Journal letters, Earthshine on a Young Moon, explaining the lunar far side highlands. Let's see this one by him. So I like it that they put links. Heights of lunacy. There is no dark side of the moon, really. Matter of fact, it's all dark. Oh, wow. It's all dark. That's really interesting, you all. To hear him say it's all dark. Yeah. That's pretty. Yeah, you all can click into those links right there that we see on this thing. Did I do that? Did I have that on there, you all? Don't tell me I didn't let you all see that. Did I let you see it? It's all dark. Is that what Pink Floyd said? Did I do this, you all? I went right here to where you could see that 55-year-old dark side. And then, because this is how you can get to them, you click right here and you can see heights of lunacy. And then you click right here, the necessary evidence, where he says the lunar far side highlands, average near side crust. Wait, you all? Yeah, this is where he said the moon has a near side and a far side. It does not actually, it has a dark side or a light side, at least not just look, there's no dark side of the moon, really. Matter of fact, it's all dark. That's what he said. The moon is all dark. That's a powerful statement. It really is a very powerful statement, you all. The moon is all dark. Boom. Okay. So what they did was remarkable to demonstrate the power of this explanation. And they considered the event that created the early Earth-Moon system and followed the potential paths of its physical evolution. The moon itself winds up forming from a circumplanetary debris disk that surrounds the Earth. You all, have you heard of this? Yeah. If the Earth is very hot, certain elements will be depleted the closer they are to Earth within its disk. Elements such as calcium and aluminum. In other words, the heat emanating off of the early Earth creates a chemical gradient within the disk, leading to a differing composition for the side of the moon that's closer to the Earth versus the side further from the Earth, you all. We're still reading. We're almost done, you all. We are. The very strong tidal forces from the Earth. Remember that Earth is very massive compared to the moon, about 70 times as massive, and that the moon was closer to Earth in the past. It could very easily have resulted in the moon forming already pre-locked to the Earth. If this is the case, then the greater abundance of calcium and aluminum in the farther part of the circumplanetary disk should lead to a thicker crust for the lunar far side as compared to the near side. A chemical compositional gradient to the proto-lunar disk as the moon is forming, therefore, could be preserved today as a difference between the moon's two hemispheres. If the moon were rotating rapidly like a barbecue chicken on a rotisserie, well, that's a nice way how to explain it, you all. I like that. If the moon was rotating rapidly like a barbecue chicken on a rotisserie, this would not be possible. But if the moon experienced practically instantaneous tidal synchronization with the Earth, it would be all but inevitable. That's right. Oh, look at this lava flowing. In late 1969, lava could be seen flowing into Aloe crater during the eruption of Mauna Ulu. When a rock gets dropped into the lava, whether from Earth or from an extraterrestrial impact, an impact crater will not remain, as the liquid will simply reform around the impact site. This applies to molten material on the moon. I did not know the molten material. There's molten material on the moon. Did they say that it was molten and it did something else, you all? So that's kind of strange. The Maria that we see are evidence of lava flows that occurred much later, where molten rock flowed into the great basins and lowlands on the lunar surface. When they say Maria that we see, let's come back up here, you all. They had a visual on here that said what the Marias were. They gave these things names right here, these patches right here. They call them the Marias, but they call it M-A-R-E. All of these areas, like one here, this little dark areas. Right here is what they're talking about. Okay, we got that down to there, you all. Let me come back over to here. We're going a little bit fast. We got some nice visuals, you all. If you like looking at nice colored pictures, this is the thing for you. It looks really cool. It really does. So yeah, let's go back to it. So the Maria that we see are evidence of lava flows that occurred much later, where molten rock flowed into the great basins and lowlands on the lunar surface. If the near side formed with a thinner crust and a different composition than the far side, then that would explain why, even billions of years later, the two faces look so different, with different sizes and numbers of Maria on them. So when those dark lunar Maria, not solidifying until much later in the solar system's history, it's easy to understand why they're so much less heavily cratered than the lunar highlands that have been solid for so long. And when your surface becomes covered in liquid, any pre-existing impacts get erased. Like a Zamboni resurfacing ice on a skating rink. I don't even know what a Zamboni is. Resurfacing ice on a skating rink. A Zamboni? Maybe that's a machine or something. That's interesting. Similarly, any impacts during this time would simply be absorbed into the sea of molten lava. Just like meteors striking the Earth's ocean, the ones landing in the moon's ancient lava oceans didn't leave scars. The study showed that simply by having a hot early Earth near enough to the moon while it was forming, just by adding that one-sided heat source, it could create the crustal thickness difference as well as elemental and chemical differences between the two sides. This is a lunar reconnaissance orbiter wide-angle camera that we're looking at right here. You can see, I guess, different twirling around of the moon. They had to piece it together. Oh, this is neat, you all. Let's make it big. Let's look at the different images. Let's get myself out of here. Let's look at this because they got it twirling around. The Lunar Reconnaissance Orbiter wide angle camera, putting the images together of the other side of the moon with all these craters on it, you all. It looks pretty cool. I've never seen it before. Arizona State University. NASA NASA Goddard, Arizona State University. At long last, after more than a half a century, you all, pondering the mystery of the moon's far side, we can confidently state not only how the moon formed, but why its two faces are so different. We know that the moon shines by reflecting the sun's light, but who would have imagined that it was the young Earth glowing bright and hot in the moon's sky that would make the two sides so different? And yet, that's precisely the explanation that works. No matter how wild or unusual your ideal may be, if it has sufficiently strong explanatory power to account for what we observe, it just might be the necessary idea to solve whatever puzzle it is that you're considering. That's just part of the wonder and joy of science and the thrill of finding out the secrets of our reality. Oh my goodness gracious, you all! That's a pretty good. That is a happy. That's a happy article. Space and astrophysics. Isn't that nice? It's a nice, happy feeling to their article. No bad mouthing. No negative overtures. No nothing. You all. It's like I kind of liked it. I did. I liked how that was written. It was wonderful. It was absolutely wonderful. It starts with a bang, September 28th, 2022. That's right. I like to giggle because it made me smile. It did. I love it, you all. So it really is true. If you come down here to the very bottom of the article, y'all, this really is true. If you come down here, when they're talking like this, it is true. Right here. No matter how wild or unusual your ideal may be, if it has sufficiently strong explanatory power to account for what we observe, it just might be the necessary idea to solve whatever puzzle it is that you're considering. That's just the part of the wonder and joy of science and the thrill of finding out the secrets of our reality. Isn't that a wonderful ending to an article? I think it's pretty cool. It is. It makes me smile. Does it make you all smile? That type of an ending. It might be too mushy for some people. They may say, oh, fake, fake, fake. Come on, you all. We got to have some enjoyment in life, and we can appreciate a good written article. It's got a good storyline, too. Never heard that theory before, and never knew what the names of those spots on the moon were either. It was Jay Ferris. That's right, you all. That's right. Yeah. You wish you would have paid more attention. Well, Penny Davis, the teacher does make a difference. It does. It does. That's right. Yeah. So I've got that in here, you all. I think I've even put this article right here in the description part of the video. It's got some nice graphics on here. Let's look at all these graphics. See, the first one they got is the moon. They got this nice graphic of the moon just twirling, and they got the dates, October through November of 2007, which is a pretty nice graphic right there. We can look at the graphics really fast. And up here, they got the names of these places on the moon right here, what they scientifically named them, which is pretty cool. And above, they got the two sides of the moon. right here, which is pretty cool too. It'd be too bad we can't just go down to see them, you all. So yeah, this is a pretty nice one right there. It looks, I love it. They did really good with their graphics, their wording, and they even showed some, you know, not too crisp images, but they put it together. Lots of dips and stuff, which is interesting. Another little graphic of the moon bouncing back and forth from the earth. And like, look at this. That's neat too, because this one area right here looks like there's something there in the cloud structure. This is a nice graphic too. And this looks like Nibiru. Boom, it does. Like Nibiru. And you might want to click on these links right here because they had some good articles in them. And we got some molten lava. And we got some more images of the moon that they shared. So it's all nice, you all. Look, you can even go here. Airless moon really does have an atmosphere. Terraforming, why the moon is a better target than Mars. 350 years, astronomers still can't explain the solar system's strangest moon. How did Mars get its 2 impossible moons? And all of that, you all. So I am going to go. Yeah, this was fun. It was. I haven't read a nice article like that in a very long time, which is great. That finally we had a decent one. Oh, you're so welcome, Susan B. Honey. You are. That's right. The live chat, was the live chat gone? My 4 gizmos. You all, did the live chat disappear? Oh, you're so welcome, Apple Brooks, you all. That's right. Oh, okay, that's great. Yeah, it's good to look at all the different theories out there. It is. There's nothing wrong with looking at them because there's gobs of theories. There really is, and I'm sure there's one that resonates with somebody. Each person, they have one or several that can resonate with them combined. That's right. So I'm going to go, but thank you all so much. And with that being said, it's only 8 o'clock. It's kind of early, but it's kind of late since it's dark out. So I hope you have a good evening, and thank you for watching. And with that being said, hello, wherever you are in any part of the world. Hello. From my heart to yours. Love you. Have a wonderful rest of your evening, you all. And, you know, you can go to that link there because it has links to other articles you might want to look at or read. Might have some very nice visuals on it, too. Yeah. Good night, everyone. Love you.